Good evening, everyone. A warm welcome to all present in this meeting. On behalf of the Department of Mathematics at Wilson College, Autonomous Mumbai, I heartily welcome Dr. Ranjan Khatu, sir, for his fourth session in this IIT JAM Mathematics lecture series, organized under the DBT Star Strengthening Scheme. Sir is an assistant professor at Shriram Kusumtai Sadashiv Vanjare College, Lanja. Sir, we are truly grateful to have you today with us. Over to you, sir. Thank you.
Thank you, ma'am. So shall I start, ma'am?
Yes, sir. We can start. It's already 7.
Okay. Okay. So I'm going to share my screen. Okay.
Good evening, sir.
Very good evening. Is it visible to all this screen?
Yes, sir.
Yes, sir.
Okay. 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 So that was our last problem, right? Suraj,
Yes.
shall we start?
Sir, last time you gave us a homework.
Yeah. You completed that?
Yes, sir. The answer was 2.
2 answers were correct.
No. The answer is 2, sir. Maybe.
And okay.
The way I have solved.
Okay. Actually, I don't have the final answer of this problem. Simply, I wrote the question only. Anyone has got the
Sir, the 13th question. The value of double integral 0 to pi 0 to x sin y by pi minus y.
Okay.
13th.
13th. Yes. The final answer is 2 you got, right?
Yes, sir. I got 2.
Yeah. Has anyone got the same answer? Akash, what about you?
Sir, I've forgotten this, sir.
Okay, no problem. What about others? Since I don't have the answer of these problems, I need to check. If anyone has got the same answer, then we will move further.
Yes, sir. I got the same answer. The answer is 2.
Yeah. That means both of you are correct then.
Yes,
What
sir.
about others? Anyone has tried for it?
Yes, sir. I have also got 2.
Yeah, very good. So let's move further. Okay. So as I told you in last lecture, today I have planned to cover some problems on spherical coordinate system and differentiable function and iterated limits getting. Okay, let us start. Okay, this problem we have problem number 21, right? So they have given this function, right? F of xy is equal to what have they given here? 2 ln means log base e x square y square e raised to y by x. And they have asked to calculate this x divided by x plus y divided by y. Okay. So let me note down the function first. Instead of ln, I will write log. Actually, it's log base e log x square y square e raised to y by x. So it looks complicated. We have to find partial derivatives. So I will use some basic properties of logarithms and I will simplify it. So will you help me to use those properties? Are you familiar with these properties? Log x into y. Suraj, what is it?
Log x plus log y, sir.
Shall I use this property here?
Yes, sir.
Yes, sir.
Okay. What will I get then?
Sir, firstly, we can send the 2 to the power and then we can apply this.
Yeah, in that way also you can do, but I think if you do it in this way, it will be better getting. So
Okay,
2
sir.
log x square, 2 log y square, right? Plus 2 log e raised to y by x. What will happen now? There is one more property of log. If you have log a raised to n, what we write here? N log a. Agree, Suraj?
Yes, sir.
Harshita, what will I get if I use this property? This 2 will come further, right? X square, that 2 will come further. And 2 into 2, what will you get here?
4
4
log.
log x. Okay.
4 log x plus
4 log y.
And in case of the third term, the log and e will get cancelled. So 2y by
Y
x.
by x. 2y
Now
by
it looks very simple. Okay, we can easily find the derivatives. So I will ask Sasmaya to find the partial derivative of f with respect to x. Can you find it?
Yes, sir. 1 minute.
Huh? Okay.
So 4 by x minus 2y by x square.
Yeah, it's very simple. It's 4. Derivative of log x is 1 by x.
4 by
Derivative
x minus 2y by x square.
0. It's 0 minus 2y is constant. Derivative of 1 by x is minus 1 by x square. Okay, so after that, what we want, please check the question. We want x divided by x plus y divided by y. That means we need to multiply divided by x by x. What will I get then if I multiply it by x?
4 minus 2y by x.
2y by
By x minus 2y by x square. If you multiply by x, you will get 4 minus 2y by, okay, this is equal to say, 4y by x. Okay. See, now I will find derivative of f with respect to y. Dab by dab by y. I will ask Khushi to find its value. Dab by y. Khushi, can you find?
Sir, 4 by y plus
Yeah,
2 plus
plus
2 by x.
2 by x. Now we need to multiply it by y. F y divided by y is equal to, if you
4 plus
multiply,
2y by x
yeah, if you multiply both sides by y, you will get 4
plus
plus,
2y by x.
yeah, now we need to simply add x divided by x, y divided by y. If you add, what will you get? Simply add these two terms. 4 plus 4 you will
8,
get
sir.
8, and
8.
minus 2y by x and plus 2y by x will get cancelled. Agree?
Yes, sir.
Yes, sir.
Yeah, so
Yes,
this is
sir.
the final answer. Okay. So after that, we have this problem. Let me read the question. So we have one function f of xy e raised to y x square plus y square for all x. Which one of the following is true? Okay, so let me note down the function first. That is important for us. F of xy is equal to what we have, e raised to y x square plus y square. This is a function we have, and we have to choose the correct option. Number of points at which f has local minimum, number of points at which f has local maximum, number of points at which, again, minimum. Okay, just a minute. It's I think it is not visible to you. Let me show you. Shall I? Yeah. Minimum is 2, maximum is 2, minimum is 1. Is it visible now? Maximum is 1.
Yes,
sir.
Yes, sir.
Yes, sir.
Was hiding this that screen, so that's fine. Okay. See, now we are interested in number of maximum point, that means maxima and number of minima, right? In last lecture, we have already discussed the method. What we do here, we find fx, we find fy, we find fxx, we call it as r, fxy, that is s, and fyy, that is t, right? And we compare fx is equal to 0, fy is equal to 0. We compare them with 0 and we find the stationary points, right? Suppose AB is a stationary point. And if RT minus S square is greater than 0 and R greater than 0, then what we get?
Minimum.
Minima, sir.
RT minus S square greater than 0 and R less than 0. Then what we get?
Maxima.
Maximum.
Maximum. RT minus S square less than 0. Then what we get?
Saddle point.
Saddle point.
And if unfortunately RT minus S square is equal to 0, then
Test will fail.
Test fails.
Fail.
test fails. Getting it unconclusive. So yeah, let us find. Okay, so that means I need to find all partial derivatives first. Fx. Suraj, will you help me to find its derivatives with respect to x?
Yes, sir. Just a minute.
No problem. Take your time.
Sir,
Sir, it's
fx is
2
e raised to
x
y into 2x.
e to the power y.
Yeah, e raised to y is a constant, right? You
Into
need to
2x.
focus on this bracket only. and its derivative of this bracket with respect to x will be 2x. Agree?
2x.
Yes, sir.
That means we are getting 2x e raised to y, right? Fy, derivative of f with respect to y. I will ask, Arif, can you find derivative of f with respect to y?
Yes, sir.
Please.
So it's e to the power y
Yeah, u into
into
v,
within
right?
first
You are using
bracket.
u into v formula, right?
Yes, sir.
E
Into
raised to,
within first bracket x square plus y square plus 2y.
yeah. So e raised to y as it is, derivative of this bracket is 2y plus second time the bracket as it is, and derivative of e raised to y will be e raised to y itself, right? Right, Arif?
Yes, sir.
Okay.
Yes, sir.
So we
We
need
will
to
take
find,
e to the power y as common.
yeah, e raised to y we can take common. Very good. So you will get in bracket x square plus y square plus 2y, right?
Yes, sir.
Okay. So let us go for fxx. Derivative of fx with respect to x. Who will find it?
The 2 e raised to power
Two
y.
Yeah, it's quite simple. 2 e raised to y. We call it as r s fxy. Derivative of fx with respect to y. Fx, we have fx here. It's a derivative with respect to y.
2x e
2x.
raised to power y.
It is
Same ही
the-
रहेगा.
Yeah, same, no? 2x e raised to y. Now t fyy, derivative of fy with respect to y. We have to take its derivative with respect to y.
So
Please,
e raised to power y.
u into v you are using, right?
Yes, sir.
Multiply
Yes, sir.
e raised to y.
E to the power y. X square plus
X
y square
square
plus
plus y
2y.
square plus 2y.
Okay, x square. That means derivative of e raised to y is e raised to y. So we are copying the
Yes.
second bracket as it is.
Plus
Plus
4y. 4y.
e,
Plus e raised to power y into 2y plus 2.
exactly. E raised to y as it is now. And derivative of that bracket will be 2y plus 2. Shall I take e raised to y common?
Yes,
Yes,
sir.
sir.
What will I get in bracket then?
X square plus y
Plus
square
4y. Plus 4y plus 2.
plus 4y plus 2.
That's it. Yeah, I got RST now, right? Okay. So now we have to find stationary points. So for that, I need to consider fx is equal to 0 and fy is equal to 0. What is my fx? Let me check. It is 2x e raised to y. 2x e raised to y is equal to 0. And fy, let me write here e raised to y. Just a minute. E raised to y and x square y square plus 2y. X square plus y square plus 2y. Okay, let me check again. Same thing I have written. Yes. See, we have to solve these two equations simultaneously, right?
Yes.
So when you think about the first term, 2 cannot be 0, right? E raised
To
to
the
y,
power.
exponential function cannot be 0. That means the only option is here, x is equal to 0. Agree?
Yes, sir.
So when you
Yes.
think about the second equation, exponential function cannot be negative, right? So what is the only option you have? That bracket will be 0. We are getting product 0. That means one of them is 0, but the first term is non-zero. That means obviously the second term is 0, right? So let us put this x is equal to 0 in this equation. So you will get 0 plus y square plus 2y is equal to 0. I will take y common. So you will get y plus 2 is equal to 0. It means either first one term is 0. Okay, I want some more space. Just a minute. Just a minute. Yeah, okay. Yes. Okay. So, yeah, y is equal to 0 or y is equal to -2, right?
Yes, sir.
So what are my stationary points therefore?
0, 0 and 0,
0, 0 and
comma
0,
minus
0, 2, 0 minus 2.
Are
0, 0 and 0 minus 2.
stationary points. Okay, I will discuss the first stationary point 0, 0 at 0, 0. So let us find R, S, and T. Both are 0, huh? R, where is my R here? This is my R. I'm putting Y 0, it will be 2, right?
Yes, sir.
I'm putting X 0, it will be 0, right?
Yes.
I'm putting both X and Y are 0 here. It will be 0, 0, 0, e raised to 0, 1. That means it will be 2. Agree?
Yes,
Getting?
sir. Yes,
Yeah.
sir.
Shall I write directly? We got 2, 0, 2. That means RT minus S square will be 4, which is positive. R is positive. Both are positive. Then what we get, maxima or minima?
Minimum.
Minimum.
Minima. Yes. So let us discuss the second point. Okay. At 0, comma, minus 2, right? R, S, T. X is 0 and Y is minus 2. X is 0 and Y is minus 2. Okay. I'm facing some problem here, huh? Just a minute. Is it visible now?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay. So I'm putting, what did I say? Y minus 2 and X 0, right? Akash, if I put Y minus 2 here, what will be its value?
So 2 into e raised to minus 2.
Yeah, right. And what about this one? If I put X is equal to 0 here?
Then
0.
it becomes 0.
0. Okay, so let me copy. It is minus 2 we got, and this is 0 we got, right? Let us talk about T. T. X 0, right? Y minus 2. It will be
So minus 2 e
O,
raised to minus 2.
right? So e raised to minus 2, what will I get? Minus 2 e raised to
Sir,
minus 2 minus 3.
in R, there is 2 into e raised to minus 2, sir.
In R, in R. Actually, I'm facing some problems here. R. Just a minute. Huh? Yeah, it is visible. Yeah, 2 e raised to minus 2, right? S is 0 and T e raised to minus 2
Minus 2 by e raised to power 2.
minus 2 e raised to power.
Minus 2.
Yeah, right. So R, you said, Akash, what did you say? 2 e raised to minus 2, right?
Yes, sir.
And here what we got?
T is minus 2 into e raised to power 2. Minus 2.
Yeah. So RT minus S square. Okay, RT, R minus 4 e raised to minus 4, and S is 0. That means it is minus 4 e raised to minus 4. Agree?
Yes,
Yes,
it's less
sir.
than 0.
So
Yes,
we are
sir.
getting negative. So what we get?
R is
Saddle
greater
point.
than 0 and this is less than 0.
Is it a saddle point?
Yes, sir.
Yes, sir.
Yes,
Yes, sir.
sir.
Yeah, that means only one point we got where we get minima. Only one point we got where we get minima. So what will be the correct option? Okay, only. So yeah, what will be the correct option?
Number of points.
C, sir.
Option
So we put 0, 0 in final equation. Then we get
option C. Option C.
Yeah, see, they are asking for number of points at which F has minimum, right now.
So yes, so 1. It's 1.
Only one point we get minimum, right?
Yes, sir.
Akash, is it clear? Someone was Arib, is it clear?
yes, sir.
Okay,
Yes,
someone
sir.
was asking me to put 0, 0 actually. but it is not expected. They are asking simply number of points at which we get the minimum value, right? Shall I move further?
Yes, sir.
Okay, so this is the next function we have, and we have to find the critical points. Critical points, that means simply we compare fx and fy with 0, and we find the points. Okay, we find it their solutions, and those solutions will be the critical points, and we have to count the number of critical points here. That means let us find fx first. I'm going to find fx. So what is
Sir,
this?
sorry to interrupt, but
Huh?
since this was mentioned that 0 can be put in the original equation, that is not required, I know, sir. But
Huh.
sir, if we put, then
Okay.
it will be wrong, because e raised to y by x, so e raised to 0 by 0.
Where is it? E raised to y by
Oh,
x.
sorry, I was looking at the wrong question.
Okay, I think you were solving the previous one, right?
Sir.
Shall I continue? Okay, so fx, can anyone tell me derivative of f with respect to x? U into v formula, right?
Yes, sir.
Please.
Sir, e raised to power x square plus y square.
As it is right now. And you are finding the derivative of first bracket, right?
Yes, sir.
2x.
Into 2x minus
Into 2x.
2x plus this bracket as it is, right?
Sir,
Yes, sir.
So I wrote this function as it is. I simply took the derivative of first bracket, right? Now I am writing this bracket as it is, and I will take derivative of that exponential function. Agree?
Yes,
Yes,
sir.
sir.
Okay.
yes,
Yeah.
sir.
Again, derivative of exponential function remains same. So e raised to minus x square plus y square, and into derivative of that bracket.
Minus 2x.
Minus 2x.
2x.
Okay, so it's looking complicated. To make it more simple, tell me, can I take anything common here?
Yes, sir.
What can I take common? 2x I can take common.
Into
the
power
minus
minus
x square
x
plus y
square plus y square.
Common. So what will be in bracket then? 1, right? Everything we have
1.
taken from the first term. And if you talk about the second term,
Minus x square
Minus
plus 3y square
x
into
square plus 3y square.
minus 3y square, right?
yes, sir.
Okay. So let us find derivative of f with respect to y. Okay. Now, yeah, please. I want help of Khushi. Can you help me?
Sure, sir. E raised to power minus x square plus y square into 6y
Exactly.
plus
This bracket as it is.
e raised to power minus x square plus y square
And derivative
into
of the power
minus 2y.
minus 2y. Khushi, what can I take common here?
So e raised to power minus x square plus y square and 2y.
And 2y. Okay, 2y I will take common, and this e raised to minus x square plus y square. Arit, will you help me? If I take this common, what will I get in bracket?
So 3 minus x square minus 3y square.
3y square, right? Okay, so whatever we want, we got those things. So I will consider only, I will solve these two equations simultaneously. Fx is equal to 0 and fy is equal to 0, right? Fx, what is my fx? 2x e raised to minus x square plus y square 1 minus x square minus 3y square is equal to 0, and 2y e raised to minus x square plus y square. We have to solve these two equations simultaneously, right? So let us focus on the first equation. 2 is constant, agree? 2 is constant. If you divide both sides by 2, it will get cancelled.
Yes,
And
sir.
this exponential function cannot be negative. Oh, sorry, cannot be 0. So what will be the option? Either this x is equal to 0.
X is 0 or 1 minus x square minus
Yeah,
3y
that
square.
means that bracket is equal to 0. So by solving it, I get x square plus 3y square is equal to 1, right?
Yes, sir.
Okay. So in the same way, if you solve the second equation, see here 2 is a constant, it cannot be 0. This exponential function cannot be 0. So only two options we have, either this y is 0 or that bracket is 0. Agree?
Yes, sir.
Square minus 3y square, plus 3y square is equal to 3, right? Actually, we have
Yes.
or here, we have or, and here we have and, right? Here we have and. So we will consider all possible combinations. See, that means the first combination will be x is equal to 0, y is equal to 0. I have taken the first one and first one here, right? Suraj, correct?
Yes, sir.
So
Yes,
now
sir.
consider x is equal to 0 and this one. So what will I get if I consider x is equal to 0 and this one? That means simply put x 3 square is equal to 3. 3 cancel, y square is equal to 1, right? So what
Plus
will be the
minus 1.
plus minus 1, plus minus 1, plus minus 1. That means here the points will be 0, 1 and 0, minus 1. Okay?
Yeah.
Agree?
Yes.
How
Yes.
many stationary points we got? This one, and this one. 3 stationary points we got right now. Okay, but we have to solve the remaining equations also. Now I will consider this one and this one. That means y is equal to 0. So put y is equal to 0 here. Y is equal to 0. And this x square plus 3y square. I'm solving these equations. Y is equal to 0. If you put x square is equal to 1. So what will be the values of x?
Plus or minus.
Plus minus 1, sir.
Minus 1.
Minus 1. That means stationary points will be 1, 0, and minus 1.
Minus 1.
Agree? This
Yes.
one and this one. So last possibility is these two are same. See, but it is not possible. No? So left hand side are same here, you can see. And right hand sides are different. You cannot consider that case. So how many stationary points we got total?
5.
5, sir.
5. Okay. So let me the correct option. Just a minute. 5. They are not given options here. So the final answer is 5, right?
Yes, sir.
Yes, sir.
Let's move further.
Sir.
Sir, we were asked to find the number of critical points here, right? And that's
Yeah.
5.
Yes. Number of critical points they are asking. Okay.
Sir, either a point can be saddle, maxima, or minima. So, what is the interpretation of a critical point or a stationary point? What is the meaning of it?
Actually stationary points, that means where the partial derivatives 0. Okay.
Okay, sir.
Yeah, that means the point in R to R function, f from R to R, stationary point is a point where the tangent is parallel to x-axis. Stationary, either you will get maxima or you will get minima. You are getting the point? And a critical
sir.
point, that means either tangent is parallel to x-axis or it does not exist. Or it does not
Okay.
exist. Okay. But actually, the does not exist case doesn't arise here. So that's why simply we check stationary points.
Got it, sir.
Okay. This OneNote is not properly working right now on my laptop. So, okay, I'm moving it slowly. So it's a huge problem we have. Multiple correct option we may getting. So what have they given? Function. Okay, let me note down the function first. F of xy. So yeah, what we have? Xy square plus y raised to 5. Xy square plus y raised to 5 divided by x square plus y raised to 4. X square plus y raised to 4. This is for xy not equal to 0, 0. And if it is equal to 0, 0, 0, then its value will be 0. Understood now? This thing we have. Okay? Okay, correct. Yes. Xy square plus y raised to 5, x square plus y raised to 4. X square plus y raised to 4. Okay. So see what we have to do in this case, we have to find out iterated limits. Okay. So we will do all these things and at the end we will find out the correct option. Okay. So iterated limits we have to find and we have to check whether do they exist or not. Next, exactly one of the partial derivative. The second option is Now both partial derivatives we have to find out, and we have the option says exactly one partial derivative exists at 0, 0. Option C says both partial derivatives exist, and option last D says function is not differentiable at 0, 0. That means what we have to do here, we have to check, find out the iterated limits, we have to find out the partial derivatives, we have to find out whether the function is differentiable or not. These three things we have to cover, right? So let us start with the iterated limits. Okay, limit x tends to 0, limit y tends to 0, f of x1. Okay, f of x1. So this is equal to limit x tends to 0, limit y tends to 0. So xy square plus y raised to 5 upon x square plus y raised to 4. Can anyone tell me, if I put y is equal to 0 here, what will happen?
So we will get 0.
0. Yeah. So that means the value of this bracket will be 0. That means if you apply the second limit, obviously that will be also 0. Okay. That means definitely this iterated limit exists. Okay. Let us talk about the second iterated limit. In second iterated limit, y tends to 0. Just a minute. Y tends to 0. Limit x tends to 0. F of xy. Right. So this is equal to limit y tends to 0. Limit x tends to 0, and yes, x y square plus y raised to 5 upon x square plus y raised to 4. Tell me what will happen now?
So
If I
0.
make
The inner limit will be y.
Y.
yeah, it will be y. Okay, you can
Y.
check. Okay, I'm writing directly right now. This term will be 0, this term will be 0, y raised to 5 upon y raised to 4, y raised to 4 will get cancelled, and you will have y. And if you apply the limit y is equal to 0, it will be 0. Suraj, understood?
Yes, sir.
Okay. Writing directly, huh? Yeah. So yeah, the first option is correct, I think. The iterated limits exist. That first option is correct. Okay. So yes, next is partial derivative. Okay, let's start to find partial derivatives. You remember the formula of partial derivative? Derivative of fx, partial derivative of f with respect to x at point 0, 0. At point 0, 0. Kushi, will you tell me, you remember this formula? Limit, I think in a second year BSc or third year BSc you already studied. Yeah, limit h tends to 0. What is it?
So
F
can I?
F of x plus
0 plus h.
0 plus h comma 0 minus f of
Minus
0
of 0 comma 0 by h.
Divided by H.
Limit h tends to 0. Yeah. So f of, that means the first 0 plus h will be h, obviously, right?
Yes, sir. F of h comma 0
Hmm.
minus f of 0 comma 0 by h.
Yes. This is h, obviously. Huh? So if I put x is equal to h and y is equal to 0, what will you get? 0 again, na?
Yes, sir. The overall answer will be 0.
Yes.
0. 0 minus 0 upon h. Am I right?
yes
Or no?
Yes, sir.
Yes. So it will be 0. That means
0.
this partial derivative exists, right, Sunil?
Yes, sir.
Okay. So let us talk about fy 0, 0. In that case, what will you do? Limit k tends to 0, f of
k comma 0
0 comma k minus f of 0, 0 upon k, right?
Yes, sir.
Limit k tends to 0. So what we have to do here, हमको क्या करना है? X की value 0 डालनी है, y की value k डालनी है. तो क्या आएगा देखो? If I put x is equal to 0 and y is equal to k.
k minus 0 upon k.
K
So we
minus
will
0 upon K.
Yes.
stop with k and the answer will be 0.
Directly actually she is correct. K raised to 5 by k raised to 4 minus 0 upon k. So what will be the final answer? K raised to 4, k raised to 4 will get
1.
cancelled.
One, sir.
K cancel and it's 1, right? It means both partial derivatives exist, right?
Yes,
Yes,
sir.
sir.
Yes, sir.
Right, the correct option.
B, option B is also correct.
Yeah, okay, it's not working. Some issue it has. Yeah. So what? So option A was already correct, right? Exactly, one of the partial derivative fx and fy exists. That is wrong. Both partial derivatives.
Option C.
Option C is correct.
Option C is also correct. So option C is also correct, right? So now we have to find we have to find whether the function is differentiable or not, right? So this is a function of two variables, so we can write limit hk. We have to check the differentiability at 0, 0. Limit hk tends to 0, 0. F of hk, right? Minus f of 0, 0 minus h fx of 0, 0 minus k fy of 0, 0 upon norm of hk, or you can say square root of h square plus k square.
k square.
If it exists, we say the function is differentiable. I'm talking about 0, 0. The general formula is quite different, right? So let us put the values.
The value of this limit is 0, then we say no that the function is differentiable.
Yeah. Limit hk tends to 0, 0, right? What is f of hk? H k square plus
K raised to power 5
k raised to power 5
By k
divided by
square
Divided
plus
by
plus
square
K
plus
raised to power 4.
h square plus k raised to power 4, right now?
Yes,
Minus
sir.
f of 0, 0 is 0. Fx partial derivative of f with respect to x at 0, 0 is 0 we got.
Minus
F
K.
we got 1, so it will be k, agree?
Yes, sir.
Divided by square root of h square plus k square. Okay, so this is equal to limit hk tends to 0, 0. Okay, so yeah, what will happen? Shall I cross multiply?
Yes, sir.
Hk square plus k raised to 5 minus h square k minus k raised to 5 divided by h square plus k raised to 4, and this thing also we have in denominator square root of h square plus k square, right?
Yes, sir. K to the
Agree?
power 5 minus k to the power
Yeah,
5
it
will
will
be
get cancelled.
cancelled.
No? It will get cancelled. Can I take anything common here?
So HK.
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 Hk. So you will get hk common. So you will get in bracket k minus h, right? Upon h square plus k raised to 4 root h square plus k square. So see, this is same as limit xy tends to 0, 0, right? I will express in terms of x and y. Xy, y minus x upon h square plus k raised to 4 root h square plus k square. Oh, sorry, xy, no? Yeah, x, this is x. And this is y, right?
Yes, sir.
This is
Yes,
x
sir.
and this is y, right? So, but see, when we have to solve such problems, that in that case, what we put x is equal to r cos theta. It is better to convert in polar, na? Y is equal to r sin theta. Then easily we get the answer. What will I get if I put limit r tends to 0, right? R cos theta, r
r
sin theta.
sin theta
In bracket also you will get 1r. I am taking common directly. So sin theta
minus cos theta.
minus cos theta. In denominator, what will happen? R square common cos square theta. Agree?
R square.
Sin raised to 4 theta. Agree?
Yes, sir.
Yes,
Cos
sir.
square sin square 1. So that's why I will get r,
Yes, sir.
right?
Sir,
Yes, sir.
sir, in the previous step, xy was tending to 0, 0. Then
Yes.
we converted to polar.
Yes.
And just just r tends to 0. I didn't understand that, sir. R cos theta and r sin theta, that should tend to 0, no, sir?
See. This is xy here, right?
Yes, sir.
It is moving towards 0, right?
Right,
R
sir.
represents the distance from the origin, and theta represents the angle made by that line with positive x-axis, right?
Yes,
So
sir.
when the point is moving towards 0, theta remains same. At each point, you will get the same theta, but simply r is moving towards 0, right?
Okay, sir. Understood.
Okay, what will happen here? Can we cancel all r's?
Yes, sir. Sir,
Yes.
function will be non-differentiable as it depends on theta.
Yes, very good. So r will get cancelled with this r square. This r will get this r cancel. Getting, if you put r is equal to 0, there will be some functions of theta will be there. Getting, and the value of function limit depends on theta. So value of limit depends on theta. That means if you change the value of theta, you will get different values of limit. So therefore we say limit does not
Does not
exist, right? So what is our conclusions? Tell me, function is differentiable or not?
not differentiable.
Not differentiable.
Let me find the correct option. I'm moving it slowly, huh? It's not working properly. That's why not differentiable at 0, 0. So is it correct?
So
Yes,
A
sir.
and C are the correct options.
A, if is not differentiable at 0, 0. Is it correct?
Yes,
Yes,
sir.
sir.
Yes, it is
Yes,
correct.
sir.
So how
D
many?
is also right.
D are correct.
Yeah.
D is also right.
Yeah,
So
yeah.
A, C.
Yeah. Okay, I'm moving it slowly. Okay, so this is the next problem we have. Let me have a water, please. Huh? Okay, maximum rate of change of f. Okay, I think we have just 20 minutes, right? Okay, so I have to cover that spherical coordinate system also. Let us complete this problem. If you can solve it, it's very easy. Then I will move forward. Huh? We have to find the maximum rate of change of function. You know how to find it?
So we will take derivative of f of xyz.
Sir, is it the gradient?
Partial derivative.
It's mod of gradient of f. That is the maximum rate of change. Getting maximum rate of change. That is nothing but del f at that point. Okay. So you know how to find del f? Del f means what? Del
Fx
f by x,
ik.
del by y, and del by y. I will give. Okay, I will distribute this task. Okay, so we can solve it fast. Priyalakshmi will find del by x. Suraj will tell me del by y, and Yashika will tell me del by z. Priyalakshmi, del by x, derivative of f. This is our f. You can see
Cos
on the
x.
and you have to tell me its derivative with respect to x.
Square divided by x is cos x.
Cos x. That's it. Suraj, I'm waiting for your answer. Derivative of f with respect to y.
Yes, sir. It is y raised to y by 2.
So E raised to y by 2.
E raised to Y by 2.
Yeah.
E
E
raised to
raised to
Y
y
by 2.
by 2.
By mistake he said, but actually he wanted to say the same. And I think I had given the last task to
Sir, 2z. It is 2z.
2z. Okay. But see, they have given a particular point. So that's why I will find their values at that particular point. Del f at pi by 4, 0, 1. That means at a place of x, I have to put pi by 4. This is our y and this is our z. So tell me, what will I get here if I put these values here?
1 by root.
1 by root 2,
1 by
comma
root 2,
1,
1,
comma 2,
2.
Comma
comma
1,
2.
comma 2, right?
Yes, sir.
Yes,
Yeah.
sir.
Yes.
That means it is I by root 2. If you write in terms of I, j, k plus j plus 2k. Agree? So we have to find
Yes,
its
sir.
mod. So that means square root of the first term, which is 1 by 2, square of the second term 2, square of third term 4. So what is the final answer?
So root 11 by 2.
Root 11 by 2. That is the final answer. Have you understood, Suraj?
Yes.
Yeah,
Yes,
got
sir.
it.
Sir, I have one doubt.
Sorry. So someone said anything?
Sir, someone said the inverse of del is pronounced nebula, but someone said that is del. What we have to pronounce the symbol?
Gradient vector.
Gradient. Someone said, yeah, gradient. It's a gradient. Del.
It is
That is
gradient.
yeah, del of f, that is nothing but gradient of f. Grad f, you can say.
It
Okay.
is a
But
normal
someone,
vector at any point.
Sorry. Any doubt
You
you
can
have?
say
sir, but someone said it is a nebula.
what?
Nebula.
I
Yes, sir.
haven't
We
heard this.
have gradient book.
It's a
The
gradient.
It's gradient.
Okay, sir. Okay, sir. Okay, it's fine.
So in some books, it is written that the symbol is read as nebula. Nabla. Nebula.
See, just wait for a minute. Huh? It's not working again. Yes, got it. Okay.
The screen is not visible.
Yeah. I
Now
know. I
it
have
is.
some
Now
issues.
it is.
It's one note. Okay, so I think total 26 problems I have written. No, so that's why it is facing. I'm facing some problem. Getting? I had to use a different page to write all these questions. Okay, so this is problem number 26. If you feel it is easy, I will move further. Do you think it is easy? Since it is again a double integrations and enough number of problems we have solved using double integration and all. So they have given a function in this form, y upon sine y, getting when y is not equal to 0. And the limits of integration involve y sine inverse x. Any help you want, or shall I start to solve? What shall I do?
Sir, it will be good if you solve this question. It will
Okay.
be okay, sir, if you extend the lecture also.
Okay, no problem. See, function we have, right? I hope it is visible to you. Okay, but I'm more interested in limits. Okay, let us find the region of integration first. So region is bounded by x is equal to 0 and x is equal to 1, right? X is equal to 1. And limits of y are y is equal to pi by 2, right? And y is equal to sine inverse x. Agree? Okay. So we will start with the simple one. X is equal to 0. It represents
Y-axis.
y-axis. X is equal to 1 represents a line parallel to y-axis. Y is equal to pi by 2. That is again a line which passes through pi by 2 means 1.57. 1.57.
Yes,
Right? Pi
sir.
by 2 is 1.57. And this y is equal to sine inverse x. Actually, see, if you are comfortable with the graph of sine inverse x, there is no issue. But see, I will use some different technique to find it. So y is equal to sine inverse x means sine y is equal to x. Agree, Suraj?
Yes, sir.
So when you say y is equal to sine x, how do you draw the graph? You draw the graph like this. Getting? But you have
the graph of
x.
sine.
Sorry.
So you have to draw in a y-axis image.
Yeah, we need to draw in y-axis. That means you will get graph like this. Understood? Okay, but we want a part of this graph, okay, up in this region only. That means you will get a graph like this. And it will go in this way. Understood now? Yes. So the region is bounded by x is equal to 0, bounded by this y is equal to sine inverse x means x is equal to sine y. Getting? And x is equal to 1. That means this is the region of integration. So I personally feel that this is very difficult to solve this problem directly. So it is better to change the order of integration. So tell me the given strip is parallel to x-axis or y-axis? Given strip is parallel to x-axis or y-axis?
Y-axis, sir.
Y-axis.
Y-axis. So to change the order of integration, I will draw a strip parallel to x-axis. Agree?
Yes, sir.
Okay. So can anyone tell me the limits? You remember now what we say x varies from first, and then we write y varies from bounded below, bounded above. You remember all these fundas, na? Bounded below, bounded above, then bottom to top. Bounded below by what? X is equal to 0.
0 to sine y.
0 to sine y.
Yes. And y? Tell me what about y? Now we have to
0
go straight
to
from
pi by 2.
0 to pi
0
by
to
2.
pi by
0 to
2.
pi by
0 to pi by
so I is equal to
0 to pi by
0 to pi by 2 and 0 to sine y, right? So what is the function we have? It is y upon sine y. For y is equal to 0, along x-axis it is 1, but we want a region. We have a region, no? So y upon sine y, I will write y upon sine y. I should write dx first, since our strip is parallel to x-axis. So tell me how to solve this one.
So
The
the
y by
integration
sin
will
x
be
is a
x.
constant as
मतलब y by
constant.
sin
Y
y
upon
will be
sine y is a
constant.
constant.
y
You
by
can
sin y is constant.
Sir,
integration
further
of,
we can do.
yeah, you can solve it further, na?
Yes, sir.
Yeah, very good.
Sir, actually, there is a constant
pi
1 by
square
pi
by
square
2.
also in the integration in the question.
Sorry.
There is a constant 1 by pi square also.
1 by
Yes, sir. 1 by pi square.
The value will be
I
get
forgot.
multiplied
Yeah,
by
yeah,
1
yeah,
by
yeah,
pi,
yeah,
pi
yeah.
square.
Thank you. This 1 by pi square is also there, right? You are right. That means whatever we get by solving this integration, finally you need to multiply it by 1 by pi square. Okay, I forgot actually. I simply focus on the integration. 1 by pi square is there. Thank you. 1 by pi square is there. Here also you can write 1 by pi square. Agree?
Yes, sir.
Yes, sir.
It is not visible. Just a minute, huh?
So what is the final answer of that question?
The final answer of this question is I need to
0.25.
solve. I haven't solved it.
0.25.
Okay, sir.
0.25. Okay, I don't know.
So we can solve it from here. You can move.
Hmm. Yeah, it's visible now.
Yes.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so it's yeah. This is the next problem. This is the next problem. So they have given a function. I think our problem number 23 or 24 is similar to this one. So we have a function like this. They are asked to check whether function is continuous or not. Getting? They have asked, that means these options we have, and multiple options are correct here. F is continuous and both fx and fy exist. F is differentiable, fx and fy exist, and f is not differentiable. Okay. So will you try for this problem? It is similar to the problem number 24.
Yes,
Yes, sir.
sir.
Yes.
You can do it now.
Yes, sir.
sir.
We can do it.
Okay. So let us come to the last point now, spherical coordinate system. Okay.
Sir, could you just show that question so that we can just take a
Yeah.
screenshot?
So see, this is my last lecture, so I'm going to share the entire PDF with you, right?
Okay, fine.
If you want, you can take, no problem. If you want,
Okay.
okay.
Then fine, sir. We'll move on. We'll move on.
Okay. So see the last point, spherical coordinate system. Spherical coordinate system, that means when you have a sphere, when you have any problem of sphere, we go for spherical coordinate system, right? So in Cartesian coordinate system, we use the variables x, y, and z. But to convert a problem in spherical coordinate system, we need to put x is equal to rho sine phi cos theta, y is equal to rho sine phi sine theta, and z is equal to rho cos phi, right? And value of dx, dy, dz will be rho square sine phi d rho d phi and d theta. So let us try to understand what is meaning of rho, phi, and theta. Suppose this is x-axis, this is y-axis, and this is z-axis. And I'm choosing any arbitrary point x, y, z. Okay, I'm choosing any arbitrary point x, y, z. What will I do? I will join this point with the origin. 0, 0, 0. So there is some direct distance of this point from the origin. So we call it as rho. Getting the point? This is my rho. So that means just like in polar form, what we do, if you take any point, distance from the origin are similarly here, the distance from the origin is rho, right? In some books, they use R symbol also, it doesn't matter. So this line makes some angle with positive z-axis, that is nothing but phi. Getting the point? That is nothing but phi. And see, if you take projection of this line in xy plane, if you take its projection in xy plane, it makes some angle with positive x-axis, that is nothing but theta. Understood the meaning of rho, phi, and theta? Yes or no?
Yes, sir.
Okay.
Yes, sir.
Okay. So see, for complete sphere, if you want a complete sphere, let us find the limits of rho. Rho will be the 0 to the radius. Getting it may be a. Phi. What will be the limit of phi? The limit of phi is always 0 to pi. Getting what I am doing? I am rotating the point by 180 degree. That means you will get a half circle like this. Getting? So this angle is phi, no? This angle is phi. If you rotate it by 0 to 180, so you will get a half circle. Can you visualize? And theta will
Yes, sir.
be 0 to 2 pi. I'm rotating this horizontal angle by 360 degree. That means if you rotate this half circle by 360 degree, you will get a complete sphere. Is it clear to you?
Yes, sir.
Have you understood?
Yes, sir.
Suraj, what about you? Hello? Am I audible? Yeah. Shall I move further? Hello?
Yes, sir.
Yes, sir.
Okay. See, if you have the hemisphere means half sphere. When you have the hemisphere, right? Like this. In that case, rho will be same 0 to a. That means that radius of that sphere. Will you tell me the phi? What will be the limits of phi?
0 to pi by 2.
0 to pi by 2. That means we should rotate phi by just 90 degree. That means you will get this kind of part of circle, getting. And what will be the limits of theta? 0 to
0 to 2 pi.
0 to 2
2. We should
pi.
rotate, horizontal angle must be rotated by 360 degree. That means you will get this hemisphere, upper half of a sphere. Understood?
Yes, sir.
Yes,
Okay.
sir.
And yeah, if they ask to consider the region in first octant, in that case, both of them will be from 0 to pi by 2. Huh? Okay, let us move further. This is the integration we have. We have to solve it with the help of spherical coordinate system. So these are the limits of z, these are the limits of y, and these are the limits of x. So let us focus on that. Z is equal to 0. Z is equal to 0 means xy plane. Agree with me?
Yes, sir.
Yes,
What is
Yes,
the
sir.
upper limit? Z is equal to root 4 minus x square minus y square. What will I do? I will simplify it. I will take square of both sides. What will I get? Z square is equal to 4 minus x square minus y square. If I shift all these terms here, you will get x square plus y square plus z square is equal to 4. This is equation of sphere. What is
Yes,
its
sir.
radius? Tell me, what is its radius?
2.
It's root 2.
Radius is 2. Since 4 means square of 2, right? If you solve the remaining equations, again, you will get a circle, okay, y is equal to. So I will not consider that thing. Okay, so that means we have this kind of hemisphere here. So when you have a hemisphere, our limits are fixed. Rho varies from 0 to 2. When you have hemisphere, our phi always varies from 0 to pi by 2. And when you have hemisphere, our theta varies from 0 to 2 pi. Okay. So let us put all these things here. What will I get? I is equal to outer integration with respect to theta, middle one with respect to phi, and the inner integration with respect to rho, 0 to 2. Okay, so let us talk about the function what we have inside it, z square. My z is rho cos phi. What is my z? Rho cos phi. So its square will be rho square cos square phi. Rho square cos square phi, right? After that, what you have? Square root. You have a huge square root. So square root of x square plus y square plus z square. Okay, I will tell you one simple thing, that if you put all these values here, you have to put these values here. X is equal to this one, y is equal to this one, z is equal to this one. But if you simplify, its value will be rho square. So I will write directly. So it is rho square. X square plus y square plus z square is rho square. Getting rho square. And dx dy dz means rho square sine phi. We have written here dx dy dz is rho square sine phi d rho d phi d theta. Rho square sine phi d rho d phi and d theta. Okay, so this is equal to 0 to 2 pi. How many rows we have got here? Tell me. How many rows we have got here?
The 5.
So 5.
Rho raised to 5, cos square 5, and sine phi we have, and d rho d phi d theta. Okay, so inner integration with respect to phi. So what can I take it outside?
Cos square phi into sine phi.
Cos square phi into sine phi. And integration of rho raised to 5 is?
Rho raised to power 6 divided by 6.
Yes, so limits will be 0 to 2, d phi, d theta. If you put the upper limit, what will you get? 2 raised to 6, 64
64.
by 6. That means 32 by 3,
Yes, sir.
right? It's not working pen, huh? Just a minute. Just a minute.
Sir, it's 64, right? 2 raised to 6, 64 by 6.
Yeah, to cancel, right?
Okay, fine.
Yes. 0 to 2 pi. 0 to pi by 2. Now we have to integrate with respect to phi. So tell me how to solve this one. Cos square phi.
So by
D.
substitution.
Substitution, you think? Or there is any more simple way? But,
Sir, we can change sign.
see, beta gamma, what do you think? Put beta gamma. Sine raised to p theta. Cos raised to q theta. You know this formula. This is equal to half of beta of p plus
So
1 by.
we can use here 1 minus sine square phi also. That will be more
Yes,
easy.
sir.
Sine raised to
Yes, sir.
pi. Yeah. In that way also you can solve. Okay. That way also. But see, actually, I use this one more frequently. No problem. That is also correct. Huh?
Okay, sir.
1 by 2 beta of what will you get? Here power is 1 and that power is 2. So it will be 1 plus 1, 2 by 2, 1, and 2 plus 1, 3 by 2. Agree?
Yes, sir.
It's constant. You can take it outside. 16 by 3 beta of 1, 3 by 2. Integration of d theta is theta 0 to 2 pi and 16 by 3. I will convert in gamma 1, gamma 3 by 2, and in denominator addition of these two, that is 5 by 2. I'm using relation between beta gamma function. Here you will get 2 pi. Okay. So I will solve it here. So 16 by 3, gamma 1 is 1, gamma 3 by 2 is, I will keep as it
3
is,
by
3 by 2.
2 into
Gamma
1
means
gamma 1
3
by
by 2, gamma 3 by 2, agree? This is 2 pi. Gamma 3 by 2, gamma 3 by 2 cancel. So it will be 30 to 64 pi by 9, agree?
Yes, sir.
64 pi by 9. Okay, in the same way, you can try for the next problem I given here. So the difference is the region is bounded by two concentric spheres, right? So we have two spheres here, the inner sphere having radius B and the outer sphere having radius A. So in that case, what we do, our limits of rho will be A to B and the remaining part remains same. Getting? This is the, sorry, B to A, limits of rho will be B to A. This is the only difference, right? So you can try this problem at your home. This is homework for you.
Sir, in previous problem, sir, could you tell me again the limit of phi? How 0 to pi by 2?
0 to pi by 2.
Yes, sir. I also have the same one.
Okay, okay. So it's a hemisphere, no? It's a hemisphere. See, phi means what? Phi means angle made by this line with positive z-axis. That is phi, right?
Yes, sir.
Okay. Wait, huh? Okay, I will draw it here. This is phi. You want a hemisphere. So this angle must be, this line must be rotated by 90 degree. Then you will get this part of circle, right? And if you take the horizontal angle 360 degree, then you will get, if you rotate this part of circle by 360 degree, horizontal angle 360 degree, then you will get a complete hemisphere. Have you understood?
Yes, sir.
Yes, sir.
Okay. So many similar problems I have already discussed in my on
Can
my
you
channel.
explain
Sorry.
how phi, like the limit of phi is from 0 to pi in sphere?
0 to pi by 2. What are you asking? Please ask the question.
Sir, the limit of phi is 0 to pi in sphere, no?
Yeah, you're right.
So can you explain that as well?
Yes. Yeah, sure. So here we are rotating phi by 180 degree. That means this kind of circle, half circle you will get. Getting na? If you
Yes,
take
sir.
this kind of half circle and if you rotate horizontally by 360 degree, then what will you get? You will get a complete sphere.
Sphere. Yes, sir.
Understand na?
Yes.
Yeah. So that's why we
Yes, sir.
take 0 to 5 always varies from 0 to pi and theta always varies from 0 to 2 pi.
2 pi. Yes, sir. I got.
Okay,
Thank
sir,
you.
I got it.
Okay, so that's all about this. So if you have any doubt, you can ask. And if
Sir,
you, sorry.
sir, I have one doubt.
Hmm.
Sir, if you want to find the function is differentiable or not differentiable,
Hmm.
if we find the partial derivative with respect to x and check at a point and then
Hmm.
exist and they got some value,
Hmm.
and again we partial derivative with y and
Hmm.
at same point we get different value,
Hmm.
then you can say that this is not differentiable.
See, you are talking about partial derivative with respect to x and partial derivative with respect to y, na?
Yes, sir.
Yeah, both can be different, no? Both can be different. Agree with me, Akash? It is
Yes,
not
sir.
necessary both of them must be same.
Sir,
Huh?
So you can say that if both are different, then it is not differentiable.
No, you cannot say in that way.
Sir, there is a property that if one of them or both are not exist, then it is not differentiable.
Exactly, exactly. One of them or both of them does not exist. Getting na, since in the definition we use those partial derivatives. If they do not exist, then how can we find?
Yes, sir.
yes,
Because
sir.
direct. Yes, sir. Or sir, by the converse, we can also say that when a function is differentiable, then its directional derivative is exist. But like when P implies Q and not Q implies not P. So similarly, if a function is differentiable, then directional derivative exists. So when directional derivative does not exist, then it is not differentiable.
Exactly, you are right. You are right. Similarly, in I think first year BSc we studied function is differentiable and it is continuous. But if it is not continuous, then it is not differentiable. In the same way.
Sir, my internet got disconnected when you were explaining about the distance
Yeah,
from
I
the
had taken your
origin.
name also. You didn't answer. So that's why I felt that maybe
Okay.
we have the connection.
Sir, can you please repeat that explanation part, please?
Which one? Spherical
Sir.
spherical coordinate system. Okay.
Sir, I understood till the distance from the origin, that is the delta thing,
Yeah.
is
So
rho thing.
yeah. So this is a point we have, right? This is a
Yes, sir.
point. And rho means distance of that point from the origin.
Yes,
And
sir.
this line makes some angle with positive z-axis. This is positive z-axis. That is phi. Agree? And what we do, we take its projection on XY plane. You will get some point here, and I will join
Yes,
with the
sir.
origin. Then this line makes some angle with positive x-axis, that is theta.
Yes, sir.
When you want a complete sphere, then that time what we do? We take one point on the positive z-axis. Okay, we rotate in this way that point, okay, in a circular path, and we will reach up to here. That
Yes,
means
sir.
we have rotated phi by 180 degrees, 0 to pi.
Right, sir.
So we got a half part of circle, right? Now, if you rotate horizontally by 360 degree, you will have the complete sphere. That means
Yes, sir.
horizontal rotation must be from 0 to 2 pi. Clear? So
Yes,
I was
sir.
talking about limits, and I discussed few examples also here. One example and one problem I have given
Got it.
from homework. Okay.
Yes, I got it, sir.
Okay. So see, if you have any doubt, I will give my email ID to ma'am. If you can send any questions related to that, so definitely I will try to solve the questions, and I will reply to your mails also. Okay.
Hello, sir.
Yes.
Sir, the lectures on the YouTube, is it sufficient to like it is sufficient for integral calculus for GEM syllabus?
JAM syllabus, na? Yeah, actually, I have covered some JAM that I have taken some problems from JAM examination also, right? Previous year question papers. But
Yes, sir.
that is not enough. The concept will be clear to you by watching those videos, getting my videos. Lot of task is there. I actually am not getting enough time to prepare videos. So I have covered the question bank of Mumbai University, right?
Yes,
So the
sir.
concept will be clear, and you can try the previous year question papers. Then it will be enough for you.
Sir, I am requesting for your numerical analysis, sir.
Numerical, you send one message on that, na, right?
Yes,
Numerical.
sir.
Okay, I will try, definitely try. In Ganesh festival, I will get some time, and in Diwali vacation also I will get some time. So definitely I will try to cover. You have a exam on the 11th Feb.
Yeah, sir.
15 Feb, na?
15th
15th.
15 Feb.
Okay, 15th
Sunday.
Feb. Okay, I don't actually. It's around that, no, 13th, 14th, or 15th Feb. Okay, I will try to cover before it. Okay. What do you want exactly? Theory or just problems only?
Yes, sir. I want to. What is the actual concept of numerical analysis?
Okay. Definitely, I will try. So, shall we stop here then?
Yes, sir.
Yes, sir.
Okay.
Yes.
Yes.
Okay,
Hello, sir.
so someone has a doubt?
Is there? Ranjan, sir?
Hello.
Sir, I want to study more in theory. So, can you suggest some books for me to read?
See, according to me, the Apostol is the best book for the calculus getting, but maybe you will think it is difficult to understand. It depends on you. Getting for teachers, definitely the Apostol will be the best book. And for problem solving, you can use Shom series or some previous year papers also. For clearing the concept, the Apostol will be the best one, definitely, no doubt. Tom
Thank you,
Apostol.
sir. Thank you, sir.
Welcome.
So, what is the name? Can you spell the?
Tom Apostol. Tom, Tom. Apostol. Apostol.
And sir, the other one, please, for problems.
Shom series. So it is the best book for clearing NET examinations. Getting na?
Okay.
For linear algebra also, it is the best one. For my NET examination, I prepared that Shom series for linear algebra.
Yes, sir. There is topic by questions, sir.
Yeah, excellent book. That is. That means it develops the problem solving skills. Getting so for clearing the concept, you can go for Tom Apostol, but for solving the problems, you should refer books in which you will get many problems.
Okay, sir.
Okay.
Are there any more doubts from the participants? All right. So we have now come to a close on the sessions by Ranjan sir. So we are deeply honored to have you as a resource person again. I think everyone here will agree that he's truly inspirational as an educator because you're continuously motivating students towards mathematics through different ways. I mean, especially through such workshops or be it your YouTube channel. So this shows sir's immense dedication. Uh, Thank you for graciously accepting our invitation. Even last time when we extended our invitation, you heartily accepted it, and you've done the same this time as well. So I'm sure that the participants have greatly benefited from your sessions. We have shared a feedback form in the chat box. I request all the participants to kindly give your feedback because it really helps us to improve our future events. And if you don't mind, sir, can we maybe just take 1 minute, if any of the participants would also like to express their gratitude towards you, based on these 4 sessions. So I just open this,
Sure, sure.
stage for the participants, if one or two of you would like to speak. And
Sir,
thanks, sir.
sir, can you hear me?
Yes, yes.
The session was truly wonderful. Your 4 sessions. I mean, we literally enjoyed learning mathematics from you. The way we were able to solve the problems, and when we got stuck in between, you helped us, and you made us remember all the important formulas, important concepts before solving the different kinds of questions, that too which have come in the previous year question papers. So it was very nice, and we had a great time learning many things from you, sir. Thank you so much for such a wonderful session for the 4 days.
Thank you so much, Sasma. Thank you.
Sir,
Actually, I thank to Wilson College also for inviting me, and I also really enjoyed the sessions to interact with such a brilliant student. Really.
And sir, we hope to hear more from you now.
sir,
Yeah.
sir, I want to say about something. Uh, Sir, I think your interaction between student and you is very nice. I think it is like a friend, like how one friend teach other friend. Like so, it is very nice and it is very nice explanation. Thank you, sir, for come in life of us, and I think we will meet again in future, maybe.
Sure, sure, sure. Thank you, Akash. Thank you.
Sir, sir, you were very polite. I'm very afraid of integration and all thing, but you made it easy, like making that strips and all, bounding the limits and all. I felt you were very polite when we asked the questions.
Thank you. Thank you. So, but if you have any suggestions, na, you can write in a feedback. Actually, I'm more eager to listen to your suggestions, so I can improve next time.
Sir, the only feedback will be, can you please take more lectures in the previous further time?
Okay.
Sir, I would also like to say something.
Sir.
Oh,
Same
sure,
thing
sure.
from my side also. We would expect to listen more from you now.
So, sir, actually, I'm a first year BSc student, and I will be doing majors in the second year. I will be changing to my majors. So, sir, the topics which you covered in just 2 to 3 or 4 days in the last days, those are such fresh and actually complex topics, sir. These are not easy to explain and easy to understand it also, sir. So, sir, the way you teach, the way you talk, the way you interact and make sure that everyone gets the topic and the understanding of the topics, it's absolutely fantastic, sir. The sir, the way you talk, it is extremely beneficial for the students to just overcome the fear of topics, sir, and the fear of interaction too. So thank you so much, sir, for giving the, the taste of such lovely concepts, sir. Thank you so much, sir.
Thank you, Suraj. Thank you.
All right. Thank you so much, Suraj, Akash, Sasmaya, and even I guess Kash. We also shared her feedback. I mean, expressed her gratitude. So thank you so much for speaking up. Thank you, Ranjan sir. Once again, I request the participants to fill the feedback form because it really helps us, like Ranjan sir said, it really helps us to understand what students, participants would like to see more in the future. So once again, thank you all. Have a nice evening. So we can stop the session. Thank you, Ranjan sir, once again.
Thank you.
Thank you, ma'am. Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Most welcome. Most.